Okay, so let's do a practice on the next one. Oh, now I've taken it too fast. Right, we'll take this slowly. Right, so identify, assuming, okay, this is really important here, assuming the graph is only identified on the given domain. Domain means the x values, it's a word we often use, so you need to know that word as well. So this is the only values over which x is defined. Now, what do you notice about the scales? They're different. They're quite considerably different. Look, we've got 1, 0, negative 1, 2. These are quite big gaps here between 1 and negative 2, but going this way, it's going up a lot faster. So if we drew them with equal scale, basically we'd end up with a funny little squiggle in nowhere, really, and you wouldn't be able to see it. So quite often we use graphs with different scales, and certainly when you're talking about time series data, which is the sort of stuff you do use in business, they really are in different scales because you've got dollars on the vertical scale or thousands of dollars or millions or something like that, and you've either got days or months or years along the horizontal scale. So we need to be careful here about the scale because this looks quite steep, but in fact it's really steep because if you look at the scale here, it's going up a lot in the small amount it goes along. Okay, so first of all, the local minimum. Stick on your finger, with your finger, point at where you think the local minimum is on your one. Okay, then from there go up above it to see where on the x-axis does that correspond to. Anyone want to guess that? Negative point. Yeah, very good. I actually said negative 0.4, but that's close enough. So here, this is where our local minimum is, so we'll give that one an A. And to find out where it cuts, we go up to there and you think, oh yeah, it's about, so that would be at x equals negative 0.4 and y equals, what's y at that particular point? It's about minus 18. Now, the way I'm asking these questions in the test is you have to match up answers. So if you think it's negative 20 or negative 15, you'll still get it right because you'll only be able to choose negative 18. It was too hard to put in that degree of accuracy or inaccuracy in the question. So you'll just have to find the right answer. Okay, the local maximum. So the local maximum, well, there's two of them actually, but we'll go for this one here. So it's a local maximum, and we'll call that B. And that's at x equals negative 2, y equals 50. So just be careful if you're looking for the y value or the x value. The x value is the one along here, the y value is the one up here. Okay, global minimum. Where's the global minimum? Yeah, it's the same as the local minimum because we stop here and it goes up there, so there's nowhere in this area where it's defined that is lower than that. So A also, so same as A. Okay, global maximum. Is that going to be B? No, it's not, because up here it's got higher than B. It goes up to about 55. So our global maximum equals y equals 55. That's the highest value that y gets to. Now this is a tricky bit here, is the slope between x equals negative 1 and x equals 1. Okay, so what we're looking at is here, about there. We want to know what the slope is here. So what you can do is you can try and draw a tangent if you want to, which is a line that just goes next to it, or you can just sort of go for an average on either side. What I would do is say that this slope here is pretty much the same all the way down, isn't it? You can see it's not changing. You wouldn't want to go from here to here, that's not right. But if I go from here to here, that's pretty much a straight line. Okay, so what I want to do is I'm going to draw a line down there and a line there. Okay, so now I want to know what's my up and what's my along. Okay, so this number here, this is about 30, we'll say. So it's gone from 30 to 0. So that's minus 30. As it goes from left to right, it's gone from 30 down to 0. So it's gone up negative 30. And what's it done here? It's 0.5. It's gone from minus 1.5 to minus 1. So that will be 0.5 along here. So our slope is going to be equal to minus 30 divided by 0.5, which equals 60. So that's a pretty steep slope. And if you extrapolated it, if you had the whole thing, say you went up here, you can see that it does go from 0 up to 60. So that's pretty close. So that's one of the main reasons we're doing this particular question, is because people often get thrown by scales being different, and I want you to be aware of that. Okay, y-intercept. Anyone tell me that one? It's about minus 9, isn't it? It's about here. So minus 9, sorry. X-intercept, where it cuts, is here. So that one there is F, and that one's G. It cuts there, which is about 0.2, I would say. Oh, there's another one, isn't there? So there are 2 x-intercepts. There's also one at, I think it's at negative 1.1. It's hard to see because I put so much junk on top of it, but it doesn't cut quite at 1. It cuts slightly to the left of it, or maybe minus 1.05 or something like that. Okay, can anyone tell me what's the slope at negative 2? Yeah, it's horizontal, which is 0. Okay, so we have our slope at negative 2. That is our our local maximum. So its slope equals 0. Okay, well done. Tomorrow we're going to do it all on Excel. So well worth coming to learn how to do that.